Section 5.6, Equivalent Ratios. For equivalent ratios, we're basically trying to get what's on one side of the equal sign to be the same as what's on the other side. And it'll be just like fractions when we make an equivalent ratio. So here's a ratio right here of 2 to 3. And we're going to make an equivalent one, that means a one that's equal, on the other side. And we'll put our equivalent colon right there. So let's look at the same sides. So this side is the same as this side of this ratio. And this side is the same as the other side of the ratio, because it's on the right-hand side, and this one is on the left-hand side. So if we're going to times this one here by 2, so 2 times 2 will give you 4. In order for it to be equivalent, we must do the exact same thing to the other side. So we've got to times this side by 2. So 3 times 2 is 6. So 2 to 3 is the same as 4 to 6. Another example, I could go ahead and multiply this side by 3. But of course, if I do that to this side, I must do it to the other side. So 2 times 3 will give me 6, and 3 times 3 will give me 9. So that's another equivalent ratio. So it's even the same as this one here in terms of equivalent ratios. For the last one, we could multiply it by 10 if we wish. But we must do the same to one side as we do to the other. So 2 times 10 will give you 20, and 3 times 10 will give you 30. So when you're asked to give several equivalent ratios, you can start off with one of them and just multiply it by different amounts to get equivalent ones. Why does this work? Well, very simple. Remember when we times it by 2, we had to double the one side and we had to double the other side. So for this one, 2 out of every 3 are going to be strawberries. So if I double this, so I take the whole thing and I double it, I'm going to end up with this whole group twice. Now let's check out how many strawberries to the whole fruit. 1, 2, 3, 4 strawberries to 6 fruit. Or it's the same as having 2 strawberries for every 3 fruit. So it really keeps the same ratio of strawberries to fruit. You can also divide to find equivalent ratios. So nobody said you had to only multiply each side by the same thing. You could divide each side by the same thing as well. So if I divide this side by 10, 20 divided by 10 is 2. And if I divide 30 by 10, I get 3. So 20 to 30 is the same as 2 to 3. Again, if I wanted to, I could divide it by 2, because we know we can divide both of these by 2 because they're even numbers. And I'll end up with 10, because 20 divided by 2 is 10, and 30 divided by 2 is 15. So that's another equivalent ratio just by dividing. Usually you're going to want to divide each side by the greatest common factor. In other words, what will go into each side, and what's the highest number that can go into each side? Well, if I think of what gives me 15, I know 1 times 15 will give me it. I know that 3 times 5 will do it, and that's about it. What about 20? Well, I know 1 times 20, and I know 2 times 10, and I know then 5 times 4. So what's the greatest common one? And the answer is 5. That's the one they have in common. So now all I have to do is divide each side, and I'll put my colon there, divide each side by 5, and I'll end up with 3 on this side. And when I divide 20 by 5, I'll end up with 4. So the way to simplify it, or make it so that it is the simplest form, I will have to make sure that I divide it by the greatest common factor.